This is a little state machine library that I've been working on recently, mainly as an exercise in some advanced TypeScript techniques. There's a bunch of cool things going on in this code, but we're going to look at 3 specific TypeScript tips that will help you level up your TypeScript. Before we actually look at the code of the library, let's look at some tests here. Mainly, let's look at a usage of our create machine function here. I was really hoping to have all the types for this library inferred based on the config object that we pass in to create this state machine. However, I did end up having to explicitly define the event types and their payloads here. So each one of these is an event, and this is the argument we expect them to take, or the payload. Then down here in the actual argument we pass to the function, we have data, which is just the context or the data for the machine. We have the initial state, and then we have a list of possible states this machine can be in. In our case right now, that's just idle and running. And right now, in whatever state you're in, there's only one thing you can do, which is listen for events. So we have on here, which is where we set up event handlers for, say, the start or set max events. Now, when an event is fired, you can do a couple of things. You can transition to a new state. We can do some action here. And then also we can do those things conditionally. So if our context is in some state, or unless the context is in some state, we can do this. And then of course we can do the same thing with our transition. And so this was the simple library that I've been working on, but let's take a look at the code for this. TypeScript tip number 1 that we're going to look at here is how to kind of do optional generics in TypeScript. If you've used generics much in TypeScript, you are probably already familiar with this problem. The state config type here, this is the object that we see right here. This type expects 3 generic arguments: the shape of the data, or the context for that state machine, the list of states that we can possibly be in, and then of course the events themselves. And so you might expect our create machine function to need to take all 3 of those generics. However, notice the way that I'm doing this here. We have a create machine function, and it returns another function that takes the state config. And if you were looking closely, you may have noticed here that we kind of have this extra set of parentheses in here. We're calling one function, which is returning another function that we immediately call. This is kind of how I'm getting around the lack of optional generics or partially applied generics in TypeScript. The thing is, I need to be able to explicitly declare what t events is, because I haven't figured out really how to properly infer it from the state config object itself. However, I can infer t data, I can infer t state keys, and so I don't want to pass those through. Now, if create machine just took the state config directly and it handled all 3 of these generic parameters, then I couldn't define one and leave the other 2 blank. When calling a generic function in TypeScript, you need to either declare all of the generic types or none of the generic types. I guess the only exception there would be in the case where you have some defaults for some of the generic parameters. However, in this case we don't, and so we would need to declare all 3. So the simple way to get around that is to declare them as 2 separate functions, one nested inside the other. Create machine only needs 1 generic type, which we will declare. The inside function that it returns takes the other 2, which we can ignore and let them be inferred inside of our state config object here. Let's look at the other one, which is something we've actually talked about recently on this channel, and that is noInfer. NoInfer is a relatively recent addition to TypeScript, and we're using it here in the state config type. The idea here is that we want to make sure, the idea here is that the state config takes, as we've just seen, those 3 generics: the shape of the data, the list of the states that we accept, and the type of the events that we accept. And we want to make sure that we're inferring those things from the right place. So for example, let's talk about state keys. We know that these have to be strings, but other than that, they can be any state key. And we want to make sure that the state keys are inferred from the keys inside this state's object. So this is where we use tstate_key. I want to make sure that initial here is not used to infer the state key. Initial must be one of the states that's provided in here. It can't add to or limit what we can put inside of the state's object here. Also, this event config needs a state key in it, and so we want to make sure that we don't accidentally infer in that place either. So basically, we can really direct where the inference is happening by using noInfer in kind of every other place we're referencing the state key, except for the place where we want it to be inferred. We're doing the same thing with tData here. We can infer here in this data param, and then when we pass it into event config, we can say noInfer there. Now we can actually see this in action if we drop the noInfer on initial. So we can remove that, and now what will happen is TypeScript is going to use initial to infer a value for state key. So if we come back here and look at initial, first of all, we can see that the type of initial is only idle. Notice that when we're trying to transition to another state, type running is not assignable to type idle. It appears that what's happened is TypeScript has seen idle here as tstate_key for initial and has decided that that is the entire value of tstate key, and there's no other string that it could be. So running is not an acceptable type. We can also see we have a bunch of other TypeScript problems going on down here. I don't know why it doesn't just tell me that running is an unacceptable key, but that's kind of weird. We can see that without no infer, we get really the wrong behavior here. If we go back and we undo that change, now if we look at the type of initial, we can see that it can either be idle or running. And maybe if we add another state here, maybe we can call it complete. If we look at initial now, we could see this could be idle, complete, or running. And so we can see that the type of initial is properly inferred based on the state of our states object. So that is no infer. We did look at this recently, but I like this example because the examples I used in my no infer video were mainly about function arguments and how they relate to each other. I like that this is kind of a more complex object, and we can see no infer in kind of a bigger light there. So let's look at our final tip, which is variable argument function types. This one is kind of interesting. So I'm going to show you there's two ways we can do this, and I'll be honest, I don't fully understand the difference between the two. So if you do, let me know in the comments, but I'll show you how this works right now. The idea is the do function here could take one or two parameters, depending on the event that we're acting on, right? So set max as an event always takes a number. And so if you put a handler here, do is essentially like an event handler for a set max event, it will receive two arguments, data, which of course matches the data that we have here. So this is the context for the machine in its current state. And then payload here will be the event payload. And you can see its number right now for set max. If we, for example, maybe we change this to big int, now we can see we do get a type error here, and payload is now big int. So you can see that because set max here takes a number, then this do payload inside set max is going to be a number. So how do we do this? No pun intended. If we look back at the event config, you can see that we have this do function that uses a conditional type based on the payload it expects to receive. So if the payload is never, then we return a function that just takes the data. That is the type we expect. However, if payload is not never, then we expect to receive a function that takes the data and also takes the payload. Now, you'll notice this comment here. There's another way that we can do this. Let's toggle this. This one, instead of putting the conditional outside the function, it puts the conditional inside the argument specifically. So you can see if the payload is never, we have a tuple of just the data. Otherwise, we have a tuple of the data and the payload. And we spread whichever tuple we get to represent the args. We can go ahead and save this. And if we do switch from this to this, we do get a problem down here, which is actually kind of fine because I already have to do payload as never here to get this to work. This is one of those things in TypeScript libraries where you kind of have a really nice interface for other people to use inside the library. Actually writing the code to match that interface sometimes takes a little bit of finagling. I'm just going to throw a TS ignore on this line for now. If we come back here, we can see that this kind of behaves exactly the same way. One of the differences I've noticed between these two approaches is in more complex types than just a simple type here. So for example, if set max is number or string, in this approach, this works just fine. We can do string or number as the payload. For some reason, if we go, let's switch back to this other approach here. Now there's kind of a problem here where payload is any, and I can't really figure out why. So set max takes a payload of any in the case where we have something more complex than a number. If I simplify this down to just a string, this works. However, if I want it to be number or string, it becomes any. I'm not sure why this is. However, honestly, just as I'm filming this right now, I'm wondering if this has to do with distributed conditional types. And so if that's the case, let's do a quick test here. I think I can wrap both sides of this in a tuple. And yeah. Hey, check that out. Okay. Love thinking on the fly. If you're doing more complex types, you need to make sure we're not accidentally distributing that union in the conditional type. So we can wrap both sides of those like that. Okay, cool. Now, so I'm going to delete this comment actually because that is exactly the solution I've been looking for. Like I said, this project is very much a learning thing for me. And there are some more advanced techniques like this that don't always show up the first time around. One thing that is interesting though, that I don't love, and I would love to think about how to get a better error message here, when I do this. Let's add an event handler to this start event handler. So right now start just transfers you to the running state. But if we copy this function, notice that we have a problem here, and it's not exactly obvious what. Data any, payload any is not assignable to type data. It's unclear why this is data any and payload any, but ignore that and notice the count of arguments. This is basically saying that a 2-argument function is not assignable to this 1-argument function. This error message even feels backwards. There it says we expected 2 or more arguments, but we got 1. And you might say, well, it looks like we got 2. But remember, we are providing a function that matches our target signature, and the target signature provided too few arguments. So the problem here is that the start event has no payload, the payload's never, and so we just need to only take the data here. And now we can see data is exactly what we'd expect it to be. What is a way we could get around this error if we had to like move callbacks between functions easily? I think one thing we might be able to do is provide another value here. Let's go ahead and wrap this in parentheses, and we can say that or tdata payload never. So now this could be one of those 2 functions. What we should see now is that this works fine. However, payload is just of type never. If we are smart and we know what we're doing, we can delete this. Oh no, what's wrong now? Data has type any. Why would data have type any now? It should know that this is acceptable. I wonder if we can go back to just one function here instead then, and let's just make it an optional second parameter. Payload of never is an optional second parameter. That's probably the safest way to do this. So now data is what we expect. If for some reason someone expects a payload, they'll just know that this payload is undefined. Okay, those are the 3 things that I've found most interesting as I've been working on this little project recently. Quick review, they were the optional generics by way of nested functions. We also had a good showcase for the no-infer utility that TypeScript added recently. And finally, variable argument function types with some conditional types and a little bit of distributed conditional types thrown in there just for fun. So there you go. Thank you guys so much for watching. If you want to check out this code, it'll be linked in the description box below. What did you think of these tips? Let me know in the comments as well. Thank you guys so much for watching, and I will see you in the next one.